Imagine you are walking toward the entrance of a supermarket. Just as you get close, the doors slide right open. How did they know you were there? They don't have eyes to see you, and they certainly didn't just guess. Computers do not have brains. They cannot imagine, and they cannot think the way humans do. Instead, they do something called processing data. This diagram shows the specific three-step cycle every smart machine uses to work: the input, process, output model. The first block is input. A machine collects raw information from the physical world, using sensors to measure things like temperature or movement. The middle block is process. The computer studies information, checking measurements against a strict list of instructions to figure out what to do. Finally, we reach output. The computer makes a decision and performs a real-world action, like pulling open a glass door. Without this exact three-step sequence, a computer is essentially just an empty plastic box. The processing step is what gives a machine its intelligence. To complete that middle processing step, a computer needs a program. A program is simply a strict list of instructions written by a human. Inside that program is an algorithm. Think of an algorithm like a recipe. It is simply a step-by-step list that tells the computer exactly what to do to solve a specific problem. You use algorithms every day. When you brush your teeth, you follow a set order. Pick up the toothbrush, add the toothpaste, brush your teeth, and then rinse your mouth. Every step has to happen in that exact order. If you mix up the order, like rubbing toothpaste directly onto your teeth before picking up the brush, the routine fails. Computers require that same exact, perfectly ordered sequence to function. This flowchart shows a tool called an if statement, allowing a computer to look at a condition and choose an action. For example, the computer asks, "Is the room warm?" If yes, the instruction is to open the window. If no, close the window. By combining algorithms with if statements, machines make millions of correct choices every single second. There is a catch. Computers cannot directly understand human words, photographs, or music. They only understand binary data. This is a language made up entirely of zeros and ones, also known as bits. Everything a computer sees or hears must be translated into these two numbers. When you want to print a homework assignment, you click Print. That is the input. The computer then translates your document into binary data. That is the process. The printer reads those zeros and ones, putting ink on paper. That is the output. The same cycle happens when you record a voice message. A microphone catches the sound of your voice as the input. The computer converts sound waves into digital data, perhaps removing background noise during the process phase. Finally, it saves a clear audio file as the output. Before a computer can solve any real-world problem, it must first convert the physical observations it collects into binary numbers. When we link sensors and computers together to handle jobs automatically, we create a control system. These smart machines repeat the input, process, output cycle all day long without human help. Let's look at a modern farm. The input comes from a soil moisture sensor sitting in the dirt, checking how much water is in the ground. The computer runs a simple if statement. If the dirt is completely dry, it sprays water to keep the plants healthy. That action is the output. When the soil has enough water, the spray turns off. On a busy road, traffic lights use motion sensors as their input. These sensors count how many cars are waiting in a line. The computer processes this data to figure out which street has the longest line. Its output changes the light to green in that direction, breaking up traffic jams safely. Swimming pools use control systems for safety. At the top of a giant water slide, a sensor acts as the input, checking if a rider is inside the tube. Looking at this diagram, we see the logic. If the slide is occupied, the process tells the output to turn on a red stoplight. If the tube is empty, it turns on a green light, letting the next person go safely. Growing food, managing city traffic, and keeping swimmers safe are entirely different jobs, yet they all rely on the exact same logic sequence to function. One of the most advanced control systems is a 3D printer. It builds physical, real-world objects directly from digital files. The input is a 3D model file received by the computer. The process calculates layer thickness and the material. The output is the machine physically building the object, layer by layer. Depending on the instructions, these printers can output anything from artificial medical limbs and rocket parts to entire houses made of concrete. This matrix table shows our examples side by side. Whether it is a basic paper printer, a farm, a traffic light, a swimming pool, or a 3D printer, every single one neatly lines up into the exact same 3 columns. No matter how complex a machine looks, its brain relies on those 3 simple steps. We have covered a lot of ground today. We learned that control systems translate the real world into binary data and then process that data using carefully ordered algorithms and programs. Here is a graphic of a machine you probably use every week, an automatic hand sanitizer dispenser. Let's see if you can figure out the logic it uses to function. Pause the video and talk to your classmates. Can you identify the input, process, and output? Ready? The input is the motion sensor detecting your hand. The process is the if statement confirming your hand is there. The output is the motor releasing soap. The next time you see a machine doing a job all by itself, you won't have to wonder if it's magic. You now know the exact logic making it happen.